Hello, Vacho. Let's read the question. The question says here, check the correct statements on scattering of light. Okay, so here scattering, beg your pardon. Statement 1 is saying, Rayleigh scattering is responsible for the bluish appearance of sky. Okay, statement 2 saying, Rayleigh scattering is proportional to 1 by lambda 4 when the size of the scatterer is much less than lambda. Statement 3 is saying clouds having droplets of water, large scattering objects, scatter all wavelengths are almost equal and so are generally white. Statement 4 is saying the sun looks reddish at sunset and sunrise due to Rayleigh scattering. Let's find out which one is correct. So let's find out why is the Rayleigh scattering responsible for the blue color of the sky. The scattering caused by these tiny air molecules, known as Rayleigh scattering, increases as the wavelength of light decreases. The violet and blue light have the shortest wavelengths, and red light has the longest. Therefore, blue light is scattered more than red light, and the sky appears blue during the sky. This one is statement one is correct. Okay, so let's find out why Rayleigh scattering is proportional to 1 by lambda force when the size of the scatterer is much less than the lambda. Light can be examined entirely from its source. Okay, when light passes from one medium to any other medium, say air, a gas of water, then a part of the light is absorbed by particles of the medium preceded by its subsequent radiation in the particular direction. This phenomenon is termed as the scattering of light. The intensity of scattered light depends on the size of the particles and the wavelengths of the light. The shorter wavelength and high frequency scatter more due to the waveness of the line and its intersection with a particle. Okay, the wavier the line and the more are the chances of it intersecting with a particle. Okay, on the other hand, longer wavelengths have low frequency and they are straighter and chances of colliding with the particle are less. So the chances are less. So the bending of multicolored light can be seen in the afternoon due to the refraction and total internal reflection of light. The wavelength of the sunlight forms different colors in different directions. The Rayleigh scattering theory is reasoned for the red color of the sun in the morning and blue color of the sky. So let P be considered as the probability of scattering and lambda is the wavelength of radiation. Then it is given as P is inversely proportional to 1 by lambda to the power 4. Okay, so the probability of scattering will give a high rise for shorter wavelength and it is inversely proportional to the fourth power of the wavelength of radiation. So statement 2 is also correct. Okay, so why clouds? Statement 3 is saying why clouds having droplets of water scatter all wavelengths are almost equal and so are generally white. So clouds appear white because light from the sun is white. As light passes through a cloud, it interacts with the water droplets, which are much bigger than the atmospheric particles that exist in the sky. Okay, so when sunlight reaches an atmospheric particle in the sky, blue light is scattered away more strongly than other colors. Okay, so giving the impression that the sky is blue, but not in a cloud. Sunlight is scattered by much larger water droplets. So they scatter all colors almost equally, meaning that the sunlight continues to remain white and so making the clouds appear white against the background of the blue sky. Hence, given statement is true. Okay. So here why the sun looks reddish at sunset and sunrise due to Rayleigh scattering. Okay. So due to Rayleigh scattering, most of the light of shorter wavelengths are scattered like the blue, violet, and green away multiple times, scattered away multiple times, leaving only lights of longer wavelengths like the red, orange, and blue, yellow to pass straight through the observer. So this statement is also true. So here option number D is the correct answer. All the statements are correct. Thank you.